So hi, everybody. Welcome to this webinar. Thank you for joining. This webinar is going to be about replacing your batch analytics with Feldera. My name is Gert Zellweger. I'm a co-founder at Feldera. Okay, so let's get started. So the agenda for today is I'm going to essentially try to convey three things. So we're going to first kind of quickly talk about what is batch analytics and how is it done traditionally in databases you may have experience with already today. And then we learn about how to do the same thing and how it works using incremental computation in Feldera. And we're going to compare the advantages and disadvantages of both methods here. So as a starting point, right, we need some frame of reference to talk about what is batch analytics and how does it look like typically. So for the remainder of this talk, we're going to kind of rely on a standard benchmark in the database world. It's called TPC-H. It's a decision support benchmarks where you essentially have a data model that is an order system of your company, and you're asking business critical questions against this database using ad hoc queries. And so you see this data model here on the very right-hand side. I'll try to draw a little bit here to explain this a bit better. But it's a simple kind of ordering system. Like I mentioned, you essentially have two kind of key entities here, which are customers and suppliers. And then customers can submit orders here against the system. An order consists of many line items, and line items are made out of parts, right, which come from suppliers. And at the end of the day, both the suppliers and the customers are in certain nations, which are part of some region, right? So that's it. That's the essentially the data model we have, and now in this TPC-H benchmark, people will ask questions based on this kind of data. So that's essentially it. So some of the questions, right, that somebody would ask is like as defined in this TPC-H benchmark would be the first question here, Q1, where essentially they're doing a summary report for the last quarter, which, asking questions like how much discounts and tax affected the revenue of the company, or how many items were sold, right? So pretty basic stuff. And we can see the corresponding SQL code for this thing here on the left-hand side, where we see it does like it looks up this table line item, right? That is part of how the items in an order. And it has a filter where it only looks at the quarter here, starting from a given date, 1998. It's a pretty old benchmark, so the data that's generated is from the last millennia. And we're doing some group by and some order by to it, and to summarize things. But that's it, right? So that's essentially a question that would be asked in this benchmark. And this is actually the only question we're going to look at today to kind of talk about batch analytics. Right. So the key part, right, for batch analytics is it's about questions you kind of want the latest answer to, but it may take a long time or it may take a lot of resource to get to this answer. Right. And so this is kind of where Feldera comes in, where Feldera can be really helpful. Okay. So with that, I'm going to kind of switch out of the slides for just a few minutes and show you a demo. Right. So I'm going to show two things. We're going to run this TPC-H benchmark in two different systems. One is a representative for a traditional database system, which we're going to use Spark running on Databricks in this case. And what I have here is I have set up this kind of TPC-H benchmark using a very kind of simple example, so it completes quickly and everything. And we'll see we have this, different kind of SQL questions that we're asking against here Q1, and a bunch of other questions that TPC-H has as queries are defined. And we're going to now run this benchmark on Spark, right? And so it will load the data from S3. And essentially, after we have defined all those queries, it will try to get the result from them using select statements down here. And again, this is mostly a toy example. I just want to like highlight one point here that happens now. So we'll see, I started this, it's running, it's like loads or creates the tables with data, then it will go and create the views that are the different TPC-H queries. And all of this completes pretty quickly as we go through the notebook here where it executes those various steps. But the key thing to highlight is once we created all those views, we need to run the select queries, right? We need to get the results from those questions that we post. And this is actually where Databricks spends the time on, right? So this is where all your time goes. So we see now it's executing this Q1, the one we just looked at, which goes over this line item table. And this is where it spends the compute time, right? So once you want the answer from the system. And, it takes about a couple of seconds, right? So now, I just want to highlight as well, right? This is not about, like making Databricks look bad or anything. Databricks is a great tool. It's amazing technology. And it's more about highlighting the kind of the architectural, the computational differences between a traditional database that could be Postgres as well, could be anything, versus what Feldera does. Right? So we see now it's done. It executed all the queries, but it spent also some, very minimal compute time, but you get the gist of it, right? The compute time is spent at the time of evaluating the query here. That's the key point I want to highlight. So now I'm going to switch to Feldera. And so we also have here our Feldera online sandbox. And I created essentially the same SQL, the TPC-H benchmark in Feldera here using this SQL, and also connected to S3. And we're going to see again here, I created the views here, the same query Q1 that we looked at in the slide. And all the other queries up to Q10 are defined as well. So I will run this now in Feldera, and I'm going to show that essentially it will also ingest the data. And it's not a lot of data. It's a very small data set. Obviously, we can make it arbitrarily big, but for purposes of this demo, we see that it ingests the data very quickly within a few seconds. And the key point I want to highlight here is that whenever we ingest the data, we also immediately, right, update the queries or the questions that we're asking with the latest result. So here I enable the change stream now. I'm going to restart this so it will like re-ingest from start. And you see this query, the answer to this query changing in real time as we ingest more data. And once all the data from this kind of reference or benchmark data set has been ingested, the result stays stable here. So the result for this Q1 query doesn't change anymore. Right? So this is a slightly different model to think about versus the traditional database, right? Where the time of the computation to get the answer to this query happens at the time where you submit the query, whereas here it happens at the time where you ingest the data. So that's the kind of the key point I'm trying to make with this talk. So if you understand this difference, this is great, right? So this is my goal here. And we're gonna like talk about this in a little bit more with slides, just to highlight exactly what the difference is in a second, a bit more. So also let me just try to show you what happens here, right? If I make a change to the database, just to kind of iterate on this point a little bit more. So I'm gonna change the line item table now slightly by inserting something, right? And I'm gonna highlight this also in the change stream so you can see what happens. So if I do this insert, right, into line item, we're gonna see that the query Q1 here immediately has a different result. So it got an additional row inserted here, and this is highlighted in the change stream. And we see that the answer to this query Q1 was updated immediately as we essentially inserted some data, it wasn't updated at the time we issued the query and had to do recomputation. So that's it. That's basically the demo I had for you. I'm going to shut this down again, and I'm going to switch back to the slides in a second here. So let's talk a little bit about what we see in kind of more detail to understand really what's going on, right? So I'm gonna simplify this Q1, that big SQL from before that we saw here a little bit by kind of throwing out most of the things, because for purposes of understanding what's happening, what's the difference between Feldera and the traditional database, it doesn't really matter that much. So we're going to look at this Q1 simplified here, which essentially tries to answer these questions: how many items were sold in the last quarter, right? So we're doing a sum over quantities in this line item table. And we're going to have still our kind of like interval filter here, where we only look at things that were sold in the last kind of 90 days, starting from this reference date here, 1998, the 1st of December. So in order to compute this answer, right, we would go in a traditional database, we would go over the line item table and filter out, the first row here and keep the kind of the second row here. So this one and this one here. And we're going to sum up 20 and 22. And then we get to our answer here that we can present to a client, which is 42 in this case. Right? Now, this is great, right, and everything. But again, right, the key thing I want to highlight is that, as this table grows in our system, right, as we have more and more orders coming in, our company is growing, we have a lot of data that we need to chew through. So whenever we want to ask this question, we have to go through the whole data set, right, to find out the answer to this question. And this is essentially how traditional databases work. So now it's no longer just 3 items, right, that we need to look at to find the answer, but it might be, billions and billions of entries in our tables. Okay. So again, that's the key distinction, right? That's why we saw before when we looked at this in Databricks, it took all the time was in the time it took to process the answer to the query. And answers are computed at the time of issuing query. So every time you submit a query, you will have to go and compute the answer. Now in Feldera, right, the key difference is that we're essentially computing the result all the time as the data changes. So as data comes into the system, we already know what is the shape of the answer we're going to reply with. So we want to know this sum quantity field here, right, which is summing up all the entries that have been sold, all the quantities that have been sold. And now Feldera will start out with an empty data set, but as kind of data trickles in, what Feldera does is incrementally updates the answer to this query here. And so here we have these 2 lines that affected this sum quantity. So we incrementally updated it as we got new entries into our database. And so the key difference, right, the key difference I want to highlight here is whenever we submit this query, Q1 simplified here, to the system, we don't have to go and do work proportional to the data size that is in our database, but we essentially just read the answer that we pre-computed incrementally whenever the data changes that happen, any changes or inserts, updates, deletes happen to the database. So that's the key point I think that I want to make with this webinar. Okay. So just to compare the 2 things a little bit better, I want to also go over this slide here. So again, right, so we saw in a traditional database that the cost of answering query is proportional to the data size. And, the other thing that the traditional database do is if it would use storage for mostly just the tables, and, some of the things for indexes and metadata, etc. And another thing is that traditional databases, they work great, especially if you're asking a questions only once. Now, in contrast, Feldera, the cost of updating the answer for a query is proportional to the change made to the database, right? So that's just the 2 slides we've seen just before. Now, in comparison to a traditional database, Feldera, on the other hand, will use storage for tables and results, right? So rather than a traditional database, which mainly will use storage for just tables. So really, this incremental computing, right, can also be seen as like a bit of a time versus space trade-off, right? So you're kind of using more space because you have to store the results as well that you're looking for, and intermediate results to get to those results in your query pipeline. But on the other hand, you can answer queries, questions to your SQL queries very quickly. And right, so the main benefit, right, that Feldera gives you is if you ask a question and you want to ask it over and over again, and you need the latest result to it all the time, but it may be very expensive to ask this question, right? Especially if you want to compute an answer in something like Spark. Right, so I think these 2 points at the bottom, right, they highlight this in good ways. So let's say you're a data scientist, you're asking a question, you're kind of doing exploratory work where you only ask a question once. In this case, it might be perfectly good to use a traditional database. But once you move this kind of in production where you want something like a real-time answer to this question, and you want to ask it over and over again, then Feldera can be a great fit. I've got a question here. Shall we ask questions here in the Zoom chat? Yes, please do. So we're almost done, and then we can allow for questions. We can do a discussion. But yeah, please raise your hand in the Zoom chat, and then I'll unmute you. And you can also pre-post a question, and we can discuss it in a minute or 2. Okay, so the final kind of point I want to highlight here is like a quick case study that I want to show. So, this is something where once kind of like clients using our software realize this is they get excited about this, right? And so the key part is in how this works, right? So with Feldera, the model that how you're thinking in kind of changes, right? So when you ingest data with Feldera, you might want to run this on a beefier machine with many cores, and you can ingest a lot of data very quickly, and you can get to the result, right? Fast by having a costly machine. And you also need a powerful machine or many machines, because when you're ingesting now a lot of historical data, right? You're trying to catch up with all the data you've stored in the past. And so you can do that, and this might be expensive to run, but it only runs for maybe a few hours or a day. And afterwards, you can scale down your Feldera instance to a smaller machine, right? And still have the same kind of answer that you computed on the whole data set, but now continue with real-time data on a small kind of instance node. And so this is kind of like a key kind of difference between the Spark model, right? So in the Spark model, where whenever you run the query, you have to do all the computation, you always need like your big Spark cluster online running in order to do this computation, because you're chewing through all the data at the time you post the questions. Now here, you already did all the hard work earlier on the big machine when you went through your historical data. And now it becomes a much simpler time to just keep up with the real-time data that's happening, which may be much less events per second, and it's much easier to compute, especially for Feldera. And so that's a key kind of like differentiator, right, between the 2 systems, where in one case you might need an expensive Spark cluster of many machines all the time online, whereas in this case here, using Feldera, you may only have to do that during ingestion time, right? Which is something, once it clicks with customers, we see that they really enjoy this, and they really like this kind of way of handling this. All right, so pretty much that's all I wanted to talk about with this webinar. So now we have like about 10-15 more minutes for discussion. Let me also try to give some pointers here as links out. So first of all, everything we discussed here, it's kind of written down in a nice tutorial. One of our coworkers, Abhinav, did a great job. Here you can find it in the docs on our website. So Lori will post the link to this as well. And you can run all of this in our Feldera online sandbox, as I just showed you a bit earlier. So you can play around with this. And if you're like, oh yeah, I don't really do batch computing, I do other things like, I'm using recursion or something like that. So I just want to highlight that we just wrote a blog post recently where we talk about the different shapes or the different kind of use cases that Feldera is good at. So you can read that too if batch computing is not your thing. So with that, I thank you for your time and your attention. And so now I think we open for discussion and questions. So let me try to look at the chat. So everybody, you can also, I think, raise your hand if you want to ask a question. So Vinesh is asking, so I'm trying to unmute you. Right, so I asked you to unmute, so you should be able to.
Okay. Hey, Gert, can you hear me?
Yes, I hear you.
Hey, great presentation. One question. Feldera is a computation engine, right? So the results must still be stored somewhere else. Feldera computes the results and results are stored somewhere else. Is that how I should reason about the engine?
Yeah, so there's two things to this, right? So essentially we have to, so when we run these computations, right, and we compute those results, Feldera will store them as well. But Feldera is also able to write them somewhere else, right? So first of all, we do store the results because you can query them, like what I just showed you earlier in the sandbox. Like we have a way to run ad hoc queries against our engine, which just uses kind of the same batch mechanism that traditional database has to execute query. And so you can run Feldera in a way where you store the data in Feldera and you query it in Feldera. But you can also run Feldera in a way where you set up an output connector for your views or your answers that you're posing against the query. And then Feldera will take these changes or these answers to the query and write them into your database, your Redis key value store, or anywhere where you kind of want to further process query them. Or Snowflake, I think we support a bunch of different outputs that it can write to. So it's I guess in some sense more flexible than a database in what it can give you in terms of outputs and where it puts the outputs for you.
Got it. A follow-up question on that. Let's say my destination is Iceberg. Uh,
Mm-hmm.
then the changes are incrementally updated to the Iceberg table, including upserts. Is that how it would happen?
That's how it would happen, yes. I think right now our Iceberg support is not there yet, where we support writing to Iceberg.
Okay.
The reason for that is somewhat that the Rust ecosystem for Iceberg isn't there yet, so it's not so easy for us to just use a library to do this. But for example, that's like Delta table is a bit limited, but we have Delta table support where we can write, but it's not as good as Iceberg as I understand it for especially for incremental updates. But yes, so once we get on top of having full support for Iceberg, that's how it will work. But right now it's not there yet. So either we have to do the work of supporting this in our system by essentially implementing the missing features in the Iceberg Rust libraries, or we're gonna wait for the Rust libraries to catch up. So that kind of depends on what kind of feedback we get from customers as well, right? So if you're interested in getting these features, talk to us, let us know, and then we can prioritize accordingly.
Okay. Thank you.
All right, so I'm gonna check if somebody raised their hand again here, if you have any other questions. Okay, we have another question from Vinesh. Ask you to unmute again.
Hey, if someone else has a question, I will wait. If no one was asking.
Oh, nobody has a question right
Okay.
now. You're good.
So I looked at the view creation.
Mhm.
I see that Feldera is computing it incrementally. Now, let's say I'm ingesting from a source, right? And I change the definition of a view or I create a new view. Is
Yeah.
Feldera storing all the data so that it is able to compute any views?
Mhm.
Or would that be a backfill, some sort of a backfill the first time a view is created or modified?
Yeah, that's a great question. So in our current version, if you download Feldera right now, what will happen is you'll have to do a full backfill again from the source. Um, but in hopefully a few weeks, so Leonid, if he's here, yeah, he's here in the Zoom. So he's working right now, probably typing away at the mechanism that so you no longer has to do the full backfill. So what will happen is it will store, since it has stored all the data, right, which you rightly point out. We will have a mechanism where if you change a view or add a new view, we can backfill from our internal state, and we only have to do the computation by sharing many of the kind of the subgraphs of the queries. We'll only have to do the recompute really what's new here, right? And we can reuse a lot of the old, even intermediary state. So it's quite cool. We'll write a few blog posts about this. We're very excited about this feature, because I think it will also simplify the life a lot for our developers. So, I'm not sure, Leonid can probably comment in the chat when it's ready, but I think it will be ready within the next month or something. So yeah, great question. This is a great point. I hope this answers your question. So then I see Andy has a question as well, so I'll unmute him. Yeah, so if you don't know how to raise your hand, I think Vinesh just answered, but you can also just write it in the chat if you want me to let you raise a question.
Okay, great. Are you able to hear me?
Yes.
Okay, cool. Yeah, so actually one of my questions, it was about the hotel, that demo over there and this kind of analytics. Um, yeah, so essentially what I wanted to check, so to make sure I'm understanding what I'm seeing is these are queries that are getting live updated just in the same kind of pattern as you've shown here.
Yeah.
Okay, got it.
Yeah, so this I think that even though we talked about batch computing here, right, that the general mechanism doesn't change. So everything, like all the SQL you write, will be incrementally updated in this manner. And I think this is something like I'm kind of excited about because this is something I think that distinguishes it from many of the competitors, is that really any SQL you write here, right? It doesn't matter what complicated expressions you can find in your SQL code, it will be done incrementally. And that's kind of cool, right? So we also had a webinar, I think a few months ago, where we built a spreadsheet using recursion and stuff like that. And if you want to go, you can go check it out. I think it's on YouTube, and you'll see that it does the same thing, even though the SQL there is in some sense much more complicated. And
Okay, fair enough. In the question, yeah, and I guess this is probably one of your very common use cases, right? Powering these kind of analytic dashboards.
Mhm.
Okay, got it.
Yeah. So this is something that we see in many cases. Like TPC-H also, I want to point out, is it's kind of like a simpler benchmark, right? Like typically this gets a lot more complicated, right? So we see people, running things with, 200 joins or something in their pipeline. So that's pretty impressive programs, right? And Feldera actually handles this quite well, right? Which is also something that if you go look at the competition, maybe you'll find that this is something they would struggle with, which I'm happy that we actually made these things, even the very complicated SQL, work fairly well. Okay, so Andre has a question, so I'm gonna unmute you.
Hey there, guys. Great presentation so far. Had a quick question around optimization of underlying data structures that you guys are processing for highly variable data sets or data sets that are changing relatively frequently. are there any sort of optimization strategies? I'm assuming beyond just minimification, minimizing attributes or features that are actually flowing through Feldera. Are there any other sort of options as far as optimization strategies to sort of constrain the complexity and the cost associated with that variability?
Okay, so I'm trying to understand. Let me try to understand this a bit better. Are you worried about the performance of your
Correct.
pipeline, or are you worried about in terms of storage or in terms of CPU or?
I'm specifically concerned about the creation of state, so that process of retroactively going back against large data sets, and trying to sort of optimize that scenario for processing that data to get that state to then begin processing the stream of data from that point forward with that new SQL application, analytic, whatever. So in that sort of scenario, I'm envisioning, and correct me if I'm wrong, this could be my own ignorance, that if we had a Parquet-based data set with 30 different columns, but only 5 of those columns are being sort of leveraged.
Oh, yeah.
Yeah, like in that sort of scenario, like are there means of, optimization for that sort of processing scenario, if that makes sense?
Got it. Yeah, so in this case, right, what Feldera will do, if you're like, let's say you have a lot of data in your Parquet, but you're only using a smaller subset to compute something, yes, it will be smart about this in that it only will actually look and even load things only that are actually used by your queries, by the questions you're posing. So we have this kind of optimization in place. I think one thing I do want to highlight, right, is like what I mentioned earlier in the slides that it is oops, let me go back to this comparison slide, right? It is in some sense a kind of a trade-off a little bit, right? So it's not free lunch, right? There's no magic there. So in order to have the results already readily available for you, so when you ask the question, you get the result immediately and you don't go out of the computation, you do have to store the results, right? So you'll find that it probably uses more storage than, let's say, a traditional database if you're using Feldera. We do have even more work to do on reducing that state. We already did a bunch of work in this, like, for example, not using the fields like you mentioned. There's compression going on, right? Of course, and all kinds of all these good techniques that we know and we're already using. But yeah, in the end, there will be some more state than you would see in a traditional database, just because we need to have the result ready all the time. I hope this makes sense and answers your question. I think there was also something in there about the dynamic data structures that you were asking. So what I can tell you is like we do support for like more dynamic data. Let's say you have a blob of JSON, right, that you want to ingest and then do SQL-based processing on that. So we support, for example, a variant data type that is very similar if you're familiar with the Snowflake variant type. It's very similar to that. This makes sense. Okay, so it looks like we kind of answered everything for now. Of course, if there is more questions, you can always reach us. So we have a Discord channel, right? We have a Slack channel. I know many of you are already there, but in case anything happens, feel free to reach out there. Again, I want to highlight the links Lori posted to this tutorial, which we just did today together. And like check it out. You can even on the Sandbox, I think we have a way to very quickly instantiate the TPC-H queries so you can play around with them and try it out. So thank you very much.